Hello, my lovely friend. Today I come to you with a new problem. Are you ready to do this together? Okay, first pause the video and think about it. Okay, let's get started. Here we are gonna find the value of k that makes this expression true. To find the value of k, I try to bring 12 to the left side, so I will do it. K squared minus k cubed minus 12 equals 0. Now I think about 12. From 0 to 12, I have to find the one number that this number, cube of this number, and a square of this number add up to 12. From the 0 to 12, negative and positive, I consider it. I see 1 doesn't work, and for 2, I can find 4 and 8. 4 is the square of 2, and 8 is a cube of 2. So I can split 12 to two numbers, split to negative 4, it's negative 12, and negative 8, which negative 4, I say, which 4 equals 2 to the power of 2, and 8 equals 2 to the power of 3. Okay, I split 12 to the 4 and 8, so I rewrite it. K squared minus k cubed minus 4 minus 8 equals 0. Now I get two square terms with each other and two cube terms with each other. So I write k squared minus 4. For this term, cube terms, I see both have a negative sign. So I factor negative sign and write it k cubed plus 8 equals 0. That's fine. Now I can use two formula. The formula of difference of square and the formula of sum of cube. The formula of difference squared says if I have a squared minus b squared, I can write it as a minus b times a plus b. And for the sum of the cube, if I have k cubed plus 8, sorry, let me write the formula. If I have a cubed plus b cubed, I want to use this two formula for this expression. I can write it a plus b times a squared minus ab plus b squared. Okay, now I apply this formula, the first one, difference of the square for the first parenthesis, and convert it to k minus 2 times k plus 2. For the second parenthesis, I can apply the sum of the cube and write it as a k plus 2 times k squared, okay, minus 2k plus 4 equals 0. Now I look at these two terms, this term and this term. K plus 2 here and K plus 2 here is a common terms between these two terms. So I bring it out. And I will write K plus 2 times, for the first term, what's left? K minus 2. And for the second term, what's left? The negative of K squared minus 2K plus 4 equals 0. Okay, here I have two parentheses. Let me rewrite it better. I have two parentheses here. The product of these two parentheses equals 0. And we say if the product of two parentheses or two terms equals 0, one of them, at least one of them, must be 0. So I say this parenthesis would be 0. So if this parenthesis, I make it 0. So I will get K equals negative 2. It's one of my roots that if I substitute negative 2 inside this expression, make this equation true. So I will go, it's one of the roots, and I will go for the second one. First of all, I distribute this negative sign inside the parentheses. So I apply this negative that makes this K squared negative, this negative 2K positive, and for the last one, I give me the negative 4 and then change the sign here, it becomes positive. Now I will rewrite again this parenthesis, second one. How many K squared terms do we have? 1, which is negative K squared. And how many K terms do we have? 1 here, 2 here, so it would be 3K. How many constants? Negative 2 and negative 4, which gives me negative 6, equals 0. Okay, I try to apply again negative multiply this expression with negative because this expression equals 0. I can do it. So it would be positive. Positive 3 becomes negative. And for the last one would be positive 6. Anyway, now I can use the discriminant method. For discriminant method, I will have delta method equals, gives me K. I should have two roots, K1 and 2 equals negative B. B here is negative 3, so negative B, which is 3, plus or negative the square root of B squared, which gives me 9, minus 4 times A times C. A is 1 and C is 6. So minus 4 times 1 times 6 gives me negative 24. Divided by 2A. 2 times A is 1. So divided by 2. Here, under the root sign, square root sign, I have 9 minus 24, which gives me negative 15. So I see I don't have Let me write it again. Positive the square root of negative 15 over 2. I don't have real roots here, so I will go for the complex roots that I know the square root of negative 1 equals I. So I can write the square root of negative 15 as the I square root of 15. So I will do it and write it as a 3 plus or negative I square root of 15 over 2. So I could find 3 roots here. One is real number, which is negative 2. I will write all the roots here, negative 2. And 2 of them is complex number. 2 of them are complex number. One of them is 3 plus I square root of 15 divided by 2. And the third one is 3 minus I square root of 15 divided by 2. Okay, we are done here. I hope you really enjoyed. If you enjoyed, subscribe, share with your friends, and stay tuned. I will see you in the next new problem. Bye bye for now.